is we're going to have polynomials that are defined before we start. Actually, not polynomials. Function operations. Well, because they're not polynomials, because they're going to have rational exponents. If you think back, theoretically, we've done this when we did polynomial operations. John, we're going to start by defining some functions. Let's say, remember the letter in front, the F, it doesn't matter. It could be an F, it could be a G, it could be an H. It's just a way of naming the functions, okay? Now, again, we've done this. We did it with polynomials, and we even defined some different polynomials by saying f of x equals g of x equals da da da. The difference in a polynomial and a function like this is the polynomial can't have fraction exponents, right? Right. Sure. That's right. Say yes because that's the right answer. Okay. So now we're talking about some different kinds of functions. So what we're going to do is we're going to talk about addition, subtraction, multiplication, and division of these functions, right? Now when you add, okay, in the beginning, it will define f of x, g of x, maybe h of x, maybe k of x, whatever it is. It'll define some functions. And then we'll say, okay, use those functions then and tell me what is f of x plus g of x. Now, when you add, when you add, you can only add what? It starts with an L. Like terms. What does it mean to be like terms? The same what? The same ending, the same variable and exponent. Right? All right. So if you look at f of x and g of x, if I replace them, 4x to the 1/2 plus negative 9x to the 1/2, are those like terms? Yes, because the variable's the same and the exponent's the same. So my next question is, how do you combine them? How? What adds? Exponents, coefficients, what?
The base.
The coefficients. The base is actually x. This is the... John, what I was saying is this is the base. The base has the exponent hooked to it, okay? This is the coefficient, okay? So when we combine like terms, guys, we combine the coefficients, but we leave the exponents alone, okay? Don't mess with the exponents. And I say that because when we start multiplying, you'll start getting confused if you don't write it down. Leave exponents. So, David, when I add 4x to the 1/2 and negative 9x to the 1/2, what do I get? Coefficients. Add the coefficients together.
That's half and half, right?
Coefficients are these numbers.
That is negative 5.
Yes. Negative 5x to the 1/2. That's exactly right. Okay? Guys, there's lots of stuff going on around here, and I need you focused up front. Oh, forgot to record. And g of x is negative 9x to the 1/2, okay? Remember, subtraction is addition. It's just adding negatives of what you have, right? So if we change it, if we do a same, change kind of scenario, we have addition again. Same, change. So if I wanted to do f of x minus g of x, same f, same g. 4x to the 1/2 minus negative 9x to the 1/2. Is anybody confused so far? Yes? Who said yes? Confused? David, wake up.
Get up, boy.
John, we don't need comments from you. All right, if I change this to addition, so I do a same change. Now it's an addition problem. So when I add like terms. Are these like terms? Yeah. Yes, because the x and the exponent are the same. So what is 9x to the 1? Yes. Thank you, David. John, control yourself. It's okay. My gosh, John. Yes, something's going to happen. Let's change. And g of x will be negative 5x to the 1/3 plus 6x to the 1/2. All right. I've got John. Please. I'm still doing addition, subtraction. No, actually, I haven't told you what to do yet, so you don't know. First thing I want you to do is find f of x plus g of x. In other words, add them together and tell me what you get. So you're going to have to find the like terms in order to combine them. Right, David? So I'm taking f of x, and I am taking g of x. And now I want to put together what goes together. Do you see any like terms in that equation? Yeah. Yes, which ones are like terms? The halves. This one and this one. Are we all in agreement there? Okay. So what is 2x to the 1/2 plus 6x? Good job. All right, David, we're glad you're awakened with us today. All right, so now I have these two terms left. Can I do anything with those? Why? They're not the same. They're not like terms. So I just write them. So if you have something that can't combine, it's okay. You just write it. What? Let's do a subtraction and see what happens. Now, here's where you have to be careful. When you're subtracting like this and you're subtracting an entire function, you're subtracting everything in that function that follows the minus sign, okay? So what that means is I have my f of x, and from that I'm going to subtract negative 5x to the 1/3 plus 6x to the 1/2. So what I want to do is make sure that that minus sign, yes, Grayson? Yes. Yeah. I want to make sure that this minus sign, when I do a same, I do f of x is the same. I change the middle sign, but yes, everything in parentheses. Go back to what?
Wait, so we're not changing any of that?
All right. Like terms. Which ones are like terms? It's still the 1/2, right? What is 2x to the 1/2 and negative 6x to the 1/2? Negative 4x to the 1/2. And then I just write the rest because it doesn't have any more like terms in there. All right, that's addition, subtraction.
Oh, where's the one?
Again, guys. Multiplication. Tell me this. when you multiply two things together, let's say something like, and I'll make it easy, no fractions or anything, 2x squared times 6x to the fifth. When you multiply terms together, what do you do? Multiply the coefficients and add the exponents. So it's 12x7. So it's multiply coefficients and it's add exponents. Okay? That's going to be the key. Remember, this whole few sections that we're doing are things that we already know how to do. We're just doing them with fractions now instead of whole numbers. Okay, so let me define an f and a g here. Let's say f of x is negative 2x to the 2/3. And let's say g of x is 8x to the 1/3. If I asked you, what is f of x times g of x? Multiply the numbers in front, so negative 2 times 8 is... Yes, you could put the 1. 2/3 plus 1/3 is 3/3, which is 1. So you can put it there or leave it off. It really doesn't matter. Yeah. What about if I asked you, y'all got this? John? All right, when you divide, as a reminder, if I have 10x to the 5th divided by 2x to the 2nd, you divide the coefficients. We have, only difference is now we're doing it with fractional exponents. That's what I said, it's pretty easy if you think that the concept's the same. All right, divide the coefficients, subtract the exponents. Okay, so this would be 5. What's the exponent, David?
3.
What was my f of it? Negative 2x 2/3. What was g of x? 8x 1/3. So let's see if you got it. If you got it, I'll set you loose. G of x goes on top. No. All right. So David says -4. So the -4 is up top. Now look what happens. Everything stays up top when you subtract. What is 1/3 minus 2/3? Negative 1/3. Now hold up. Good job. What do you do when you have a negative exponent? You got to flip it. Now the 4 is going to stay up top. Okay, it's its own piece. It's multiplied. So it's -4 over. It's the same concept we did in chapter 2 with the properties of exponents. Tell me what you think. For real?